Hello, everybody. Welcome to another episode of Observable Flutter. I'm your host, as always, Craig LeBenz, though maybe one day someone else will host. Just as always, so far. Anyway, today I'm excited to talk to everybody about gRPC, which, for those who don't know, stands for, I believe, Google Remote Process Call. I know it was invented by Google. Maybe my guest will be able to clarify exactly what the G looks like or stands for, which I realized as I started this sentence, I've never actually looked up before. I've just assumed. But before we get too far into that, I just want to remind everybody that here on Observable Flutter, we're all very kind to each other. This is the Flutter community. Let's live up to our good name. All right. And my guest is Gianfranco, who is the CTO and co-founder of Somnio Software in Uruguay. And many of you will know him as just a delightful presence on Twitter in the Flutter community and an all-around great software engineer. So, Gianfranco, man, I am really excited to have you. Welcome.
Hey, how are you, Greg?
I'm great. I'm very excited to talk about gRPC. Maybe if you'd like, you could begin by just saying a few words about your history with tech and in Flutter, and how did we get here?
Yeah, of course. Okay, so first of all, thanks for having me here. I'm really excited. I always see a show, so being part of the show right now is really, I'm really excited. And yeah, maybe I can introduce myself. I'm Gianfranco Papa, and I'm a CTO and co-founder of Somnio Software. And yeah, I'm a software engineer who specializes in Flutter. I really love this technology. And what else? I've been growing the community in Uruguay, here in Latin America. I'm co-organizer of Flutter Uruguay. Yeah, so that's really cool. And yeah, in our company, like we are basically a dev shop that specializes in Flutter. We are like 100% focused on in this technology. Um, so yeah, we started like at the same time that Flutter actually was created. We started with the beta back in 2018, and then we keep like working in projects and realize, okay, this is like something big. So yeah, that's how all started. We basically trusted in this technology, and yeah, back then we were working with mobile apps, but now, like as we all do know, like we can work with web and desktop. So that's really great that Flutter keeps opening us doors to work in any kind of project.
Nice, yeah. I know we've met at a couple events, and I always love to meet and talk to folks who go all the way back to the early beta because I don't even I found Flutter shortly after it went to 1.0. So you've got a longer Flutter tenure than I have. But today we're not just talking about Flutter. We're actually hitting a more kind of Dart centric concept. Although the concept itself is larger than Dart, we're just going to implement it in Dart, which is gRPC. So, Gianfranco, you pitched this episode idea to me, I mean, a long time ago, basically right when Observable Flutter started. And so you knew immediately that you wanted to talk about gRPC. Tell us a little bit about why kind of the average developer should agree with you and also be excited about gRPC.
Yeah. Okay. So yeah, I remember that we talked about even before Observable Flutter was a show. We were talking about maybe the boring show. I think that I asked you to talk about gRPC because yeah, back then I think I saw a video about full stack apps, but with WebSockets. Um, so yeah, and the thing about gRPC is that it's another tool you can have your tool set to kind of like create full stack apps in Dart because as it has Dart support, you can create your front end and your back end by only using Dart, and that's really advantageous for as Flutter developers who already know a lot Dart and want to also like create backend applications, and we don't want to switch to another language, right? But I mean, we all know that there are other things, other tools we can to create backends in Dart. For example, Dart Frog or Shelf. But in the case of gRPC, I think that it's slightly different because you can not only make your backend in Dart, but you can also use other um, programming languages seamlessly. So yeah, that would be because we're going to see it, but you can basically, I mean, gRPC has support for a variety of languages, and you can basically auto generate with a thing that is called protobuf, whatever language you are targeting. So it's kind of like more or less language agnostic in a sense.
Yeah, the cross language part is a huge deal because one of the driving goals or like a value that a developer gets by having a full stack Dart application is to be able to reuse a bunch of classes and not have to duplicate logic and whatnot. And there's still, if you even if you use gRPC, having Dart on both ends will kind of put you in the best possible scenario there. But if you can't use Dart on the back end for any reason, we'll be using Dart on the back end today. But if for some reason you can't, that's a great point because those bindings are generated on both ends in a variety of languages, whether you're using JavaScript or Python or Java or whatever on the back end. The task of communicating just with yourself across that language barrier becomes so much simpler because from that simple protobuf definition you mentioned, which we'll get into, everything kind of falls out of that. And by the way, if any of you ever want to work at Google and you want to apply to Google, familiarity, like protobufs, that is what every Google developer uses every day. Everything at Google runs on protobufs and the code that is generated downstream of that. So you might be training yourself a little bit for your next job. All right, Gianfranco, I believe you are ready to kind of walk us through some steps of getting started. Are you? Am I right?
Sure. Yeah, let's get ready.
Okay, let's do
So
it.
perfect. Okay, so my idea for today, we were discussing with Craig, like to present kind of like something from from scratch. Okay, it would be something real simple, but yeah, and the idea is to make it from scratch, so it won't be something really fancy. But yeah, first of all, I wanted to like I have the documentation open here, so actually I consider that gRPC is not that topic that there is so much information like blogs, or it's not like so common such as Rust, right? Um, but yeah, here's the documentation, so you can always go and hear the official docs. gRPC is a modern open source high performance remote procedure call. So remote procedure call would be the protocol that we are going to use, just as you have REST or WebSockets. In here we are going to use RPC. And I think the G, it could be right for Google, right? I actually didn't ask that question, but probably it will be because of Google, right?
That's what I thought as well. Randall tells us that it's just one of those cheeky recursive algorithm or acronyms.
Oh, okay.
So I guess the G is officially
Okay.
not for Google. It's just
A
meaningless.
coincidence. Okay.
But since
Okay.
this was invented by Google, if they picked a meaningless letter, I'm not surprised that they picked G. So
Right. Makes sense. So, okay, and here you can get started. We have a lot of languages. Of course, we are going to choose Dart, right? But you can play around with any of these languages that are really common. And so yeah, another thing that I want to show is, okay, the quick intro. So here um, we have like yeah, an intro, and it will also talk about protocol buffers that is really tight. Is I imagine that you can kind of like look to protocol buffers as JSON for REST. The protocol buffer for gRPC will be kind of the same, the way it communicates information. But yeah, we're definitely going to explain better this term. So yeah, I wanted to like only show that. Maybe we are keeping hand the documentation for some things, but we are switching to VS Code and we are going to create a full stack app from scratch. So so yeah, the first thing I want to talk about actually is protocol buffers, right? Because maybe we can start our project by creating some protos, like it's a short for protobuf, right? And and yeah, my idea is to have like three different folders, right? One for the front end that will be made in Flutter, then another one for the backend that will be made in gRPC, using gRPC. And another one that will be the share folder that we will call it Protos, but we will use it in the backend and the frontend. And that is one of the first advantages, that we can reuse a lot of the code between the frontend and the backend.
I
Okay.
love it. Yep.
Perfect. So I'm going to just create. Okay, we are here in the terminal. I'm going to create a project. I always forget what is the template, the default template. So
You want server shelf?
no, we're going to start with the Protos package. So I'm going to select
Mm,
a package so we can store
package.
all of
Okay.
our Proto buffer files. So okay, so we're going to create using the template package, right? Oh, maybe we
Yeah.
can create the directory first. Okay, so let's create a Protos folder, and then we can move to the Protos. And here, okay, we can create the um, package, right? So if we hit package and in this directory, I think I might force this. So here we have a pure Dart package, like really simple. So maybe we can delete the test folder because we are not going to have any tests. This is going to explode sooner or later, right?
Yeah,
This
and
is
that's
not a
one of the
good practice.
nice. Well, you wouldn't really write tests for your protobufs because gRPC is well tested. So,
Right.
unless you
Yeah.
just didn't even define your model correctly, um,
Right.
you
I
you
guess
wouldn't really
you're.
have tests in this
Yeah.
folder, I don't think.
Yeah. I guess you're mistrusting the way gRPC works, right? Or protobuf.
Right.
Yeah.
Right.
Okay. So here we have an example. We have a lib folder, and the first thing to do would be to actually um, grab our dependencies, right? So we are going to use protobuf and gRPC. Okay, those are Dart packages that you can see in PubDev. So yeah, let's make sure that everything is in place. So here we have our dependencies. Let's put here the dependencies, and that's it, right?
Looks good.
Perfect. Okay. So, okay, to create our first proto file, maybe we can create a folder that will be called protos. And in here, we can actually create our first definition of our protocol buffer model. And I was thinking about a basic to-do file, but we can choose anything, right? It would depend on what you want to build. But let's start with a to-do, and the extension would be proto. Okay, so in here we can start defining like what would be the protobuf for our model. So I want to get back to the documentation so we can see the basic syntax of the protobuf. So let me search in here for the protocol buffers that it has its separated documentation. But here would be more or less the syntax that we have to use in order to create a model using protobuf. Okay, so you see that if we would like to create maybe a to-do class, we will have to use the keyword message. And then for defining every property, will have to like use this special notation where you define the name of the property and a code. That code would be like an incremental integer. Okay.
And that message keyword, that's kind of like, it's basically just like the keyword class in any other language, right? But it's
Yeah.
written as message here because the whole idea of gRPC is the ability to get this data on the wire, right? To how to
Right.
send this data somewhere else. So, gRPC thinks of all these things as messages. Their data that starts on one computer is going to go to another computer.
Right.
But it's really similar to the keyword class if you're looking at this for the first time.
Yeah, it could be. So yeah, the thing is that in order to have this connection, this interchange messages in an efficient way, gRPC protobuf, sorry, kind of like reduce the whole concept of a message that we are passing through services, so through the front end and the back end. So it can be more efficient in terms of size because if you know JSON, probably you know it, it will be something that is really easy to read, but it's not so efficient to pass over the wire. So in this case, we are not producing something so readable, but it will be really efficient to pass back and forth. Okay, so
Yeah,
maybe we
JSON
can,
wastes. Oh, sorry.
yeah,
Yeah, I was just going to say JSON spends so much time, or so, it wastes so much space with all the parentheses or the
right,
curlies and the quotes and just sending things as like raw strings. And gRPC also sends this in a binary format, so it's incredibly efficient.
right. So yeah, maybe we can start defining our first message. So I'm going to copy and paste this example. We are going to use the syntax proto3 here. And in here, maybe we can rename this to do, right? So maybe we can also remove this. So if you want to also keep in hand the documentation, we have different types that protobuf support. Let me see, but I'm searching for the types. Listen, okay, default values.
Scalar
No,
value types? No, that's just. Oh, you're on the whole list here. Yeah, you're looking for like a
yeah,
single list that shows all the types.
right, yeah, yeah,
It would be.
yeah. This is the whole list of yeah. Maybe there is a section where you can actually search all of the uh, values of your types. But that's not important. I mean, we're going to use like basic types here. We're going to use in32 for our ID. So we can define
Mm.
the name of the property and remember to define an actual value that will be an incremental value. This is just for encoding the information. And
It's
then we
basically
can use,
like the order of the fields, right? It's
yeah,
nothing more than that.
right, of course. So instead of right, like in JSON will be like you could read it. I know the ID will be this field like key value, and this will be like okay, the number one will be the ID, but nothing else. And yeah, this is has to be unique, right? So apart from that, we can define a title maybe. So this will be number two, and then we can use another type that is bool to say if this is completed or not, right? So this is in essence like our definition of our to-do message, right?
Hmm.
And we are seeing this in the proto buffer notation. But the cool thing about this is that we are going to actually auto generate this in Dart. It can be in any language, but we are using Dart. So you can start sharing your models not only with your front-end team, but also with anyone
Hmm.
that wants to implement a definition of to-do. So this is really like a really an ultimately solution for having a single source of truth for your models, right? Because you are sharing the whole model with a lot of even languages, programming languages.
Hmm. And boy,
Yeah.
did we not write much.
Yeah.
That is a terse definition of this to do class. I'll even call it.
Of course. Of course. Okay. So here, what we have to do is to create another folder that will be generated, and maybe we can remove this as it's part of the library. We won't need it. Delete. And here, okay, here we can export things later. And our library, here we are going to actually export our generated classes. So the idea is to grab using the protoc command that you can download. We skip the setup, but the idea is that you can use this setup. Let me see. Um, there is a quick start for this, but okay, so let me actually search quick start in Dart. Okay, so basically here we have to download the protoc plugin and activate it, and then export the path, and then we can start using the protoc command line in order to generate these proto files. So I'm going to copy this command because it's hard to remember. So, but we can say it. Okay, here I'm using the protoc. Dart output will be the generated folder, and we are basically grabbing everything that is under the protoc folder, every file, and we are auto-generating Dart classes. So if we hit enter, this will generate a lot of classes, a bunch of classes in Dart. And yeah, this is not so readable, but the thing is that you have your models in Dart and you can start using it. So you have your, you can actually here create an object that is to do, okay? Great. So what we can do here right now is to actually export the, let me see, the all of these files in the library. So maybe in this file we can export it. So it will be source generated and to do that protobuf.dart, and we can do it with the other ones as well, just in case we need it. But you will find that everything is that's not enum, and then JSON. So great. So here what we did is that we have to, maybe we can remove the example as well. We just define our definition of our models, and we can start sharing this package in our front end, in our backend, and we will have access to our to-do object, right? Okay, so maybe another thing we can do right now is to create our backend and in a separate package, okay?
Sounds good.
So perfect. So maybe we can go back to our full stack app and create this time a server. Okay. So I'm just creating another folder, and if we enter to this folder, here I would like to use another template because this would be a package that we can import in our front end, but maybe we can use the console app so we have our main and we can start our server. Okay, so this will be actually the default template. So if we hit Dart create, instead of specifying the template, we can use the default one, and we are going to force it to be created in this folder, in the server folder. Okay, so here we have our projects, and maybe what we can do now is to import the Protos package into our server folder so we can start using it, right? So because this is a package that we have locally, we have to basically provide the path, and we can actually say, okay, let's grab the path in the Protos folder, okay? Great. Okay, saying that, Oh, we have to add like the publish to none just really quick, so we don't
Hmm.
have that warning. Okay, perfect. All right, so the idea here would be we can also well, this is going to also explode because we have our calculate method, and inside bin we have our server.dart that is having a main function. But in here, what we actually want to do is to yeah, create the gRPC server. So anyone can start connecting with the gRPC server using a client. And yeah, one of the things that we didn't mention is that a cool thing about this protocol is that you can call a function, a remote function, as if you were calling directly in your front end. So it will be really seamless communication we are going to, when we are going to see it, but when we are going to be in the Flutter app, it will be calling the server, it will be like calling a function that we have like in our front end project. It will be really, really great. You don't have to create an HTTP request and parsing. It's like you just can call the function and that's it. But yeah, so here we have like our main file. I'm going to create the server right now. So this is also some of the code I bring just to speed up this part. So let me quickly copy and paste this. Okay, so basically we have to define a server. We're going to delete this just for now, but this server will come from the gRPC library. Oh, we have to also install this library
Yeah.
because
Yeah.
we are in the we are in the other project. We can actually export it from the proto library. Let me see inside live. We can export as well the gRPC package. So we can start using it in our server. So if you go here, we can create our server. Then we have to run our server in a in a port. Let's I don't know why. Yeah, the Dart HTML. So basically, we are retrieving the port from the environment, or as a default, we can use the 8080 port as a really default one. And then we have to name this function async because we are waiting. And finally, we can simply print like the server is listening in the port 8080, right? So I guess we don't have to use this import. And that's it. This is like our whole server, our whole gRPC server that we are going to connect in Flutter. And one parameter that we are not seeing right now is this array. This will be an array of services. That is something that we actually didn't talk about so far. So maybe we can jump in and talk about the services, right? Because till now we only define like a
The
model, a
message.
to do, right? The message,
Yeah.
but we have to define also the functions that we are going to call in our front end to communicate with gRPC, right? So to do that, we can get back to our proto file. And instead of defining a message, we are going to define this time a service that will be more or less like an interface that you need to also implement. But here we can define all of our methods that we are going to use to communicate with gRPC. So maybe we can name this to do service. And in here, we can use the notation of RPC. We have our method name, our request, and our response. So basically, this is the notation. And I was thinking about getting a simple to do from gRPC. So maybe we can name this get to do. Okay, so
Now,
here
we
we will
won't have
need,
anything to get until we create some, right?
right. Yeah, I mean, maybe we can hard code something just to see it
Okay, sounds good.
in place. Or maybe, yeah, we can also create, have a method to create a to do. Let's start with getting a
Yeah, hard
simple to do
coding's
so we
fine.
can, yeah,
Yeah.
perfect. Okay, so in here, what we will have to do is to have a, remember the method, we have a request and a response. So we will have to return something, and this is the actual keyword returns. And we actually have to create another message because we will have to have a request and a response that are also messages. So in this case, to create um, we can create a message called get to do request. Maybe it could be by ID, right? So we can add an ID to the request, and we can, okay, we maybe we can put this here. And here, as we did with the method to do, we are going to provide maybe an int 32, so we can pass the ID through the message. If we um, want to get the to by the ID, it's a good idea to send the ID. So here in our method get to do, we can put the get to do by ID request, and we can return just a to do, right? That we already put it in our, we already have a message for that. So basically, this method will be sending get to do by ID request that it has an ID, and we will returning a simple to do that. In this case, will be hard coded. Yeah. All right. So perfect. And here again, as we modify the product file, we need to auto-generate again the generated classes, right? So we have to hit again the command line, and okay, let's go back to our proto package.
And normally, if we were running build runner here, this is when we'd all get up and go get some coffee. But this is a pretty fast generation. You
Right.
blink, you miss it.
Okay, so maybe we can grab the 500, so we can access directly. And here we can notice that there is another class that was generated because we are including services right now. So in this case,
Mm.
this is not so readable, but it creates all of the communication to actually call the get to do method. So maybe what we can do right now is to export this class uh, so we can have access in our backend. So here we can
gRPC, right?
share this one,
Nice.
right? Perfect. So I think we won't be creating so much other things in our profile, but maybe we will create other methods. But we already have like a message and a service, and that's it to basically have our very first example connecting Flutter with gRPC. Okay, so let's get back to our server, right? In here, what we want to do actually is to create a to-do service so we can expose the service to our frontend. So what I'm going to do right now is to actually just create the service. But the thing is that this service, we didn't create it because we have our base service, that is what gRPC, the proto created, auto-generated, but we have to actually implement this service. So what we can do is to create a service class for this service. We're going to name it to-do service. And here we can actually create the service, and we are extending the to-do service base. Okay, so this to-do service base, what we'll have, we have like red highlight here because we are not implementing yet the get to do method. Remember that we defined that method in our service, so it more or less works such as an interface. You need to implement those methods so we can uh, basically override them. And in this case, basically what we can do is just to return a to-do, right? Like a hard-coded to-do. So we can have basic implementation of this method that is returning a to-do, okay? So one cool thing about Protobus is that you already have your to-do class. You can use it with name parameters such as here, or maybe you have different methods such as get default, and maybe this is returning no other than the default implementation with, I don't know, like empty parameters. But we can, yeah, maybe create some basic parameters. Maybe the title, we can do title.
For the ID, can we pull it out of the request? Why don't we use the
Oh yeah,
ID that was passed in?
yeah, that's a great idea. So basically, if we go here, maybe we can put final ID request dot ID, and we will use this ID instead. Perfect. So it will be like, yeah, the front end will generate the ID and we will return a new to do with that ID. And then we have the completed pattern that is missing, and this will be false. Maybe what we can do also is to provide put in the title the ID, so we can have our distinct title in a sense.
I like that.
And okay, and and yeah, another thing that we can do is, okay, to actually return the to do, right? Because this is returning a feature of to do. So here, what we are missing is the async keyword. And that's it. I mean, we are implementing this get to the method and returning it. And so, yeah, this is our definition. And now we can make use of this service inside our server file, right? So this will expose this to the service uh, in the gRPC server, and we can start using it in our front-end app, okay? And that's really it. Okay, so the last thing we need to do actually is to create our front-end app, our Flutter app, right? So we have everything running. We'll need to, in this case, create another folder. So maybe you can create a client app in Flutter. And in here, okay, we are going to create a basic app in Flutter using the template, the create template. And as I'm running my example in a MacBook Pro, maybe we can create it using Android, iOS, and macOS. We could use the web, but it's not going to work because the thing is that to deal with gRPC in the web, you have to do some special things that it doesn't have full support yet out of the box. You have to do some more advanced things. But yeah, we can definitely test it in mobile and desktop. Okay.
Sounds good. Yeah.
So maybe for the name, we can choose app. I'm going to use the Somni organization, and then maybe the platforms. We can choose, as I said, Android, iOS, and macOS. Okay, and let's create everything here. Okay, so this should create our app in Flutter. Really basic stuff. So we have our folders, iOS, Android, macOS, and we have our Fastback YAML. So maybe what we can do right now is to clean a little bit this Fastback YAML. So what we can do is to use some regular expressions to actually clean up this. So let's put, I think it was, yeah, the notation was just like this, right? Oh, and you have to select the regex, right?
Yeah. You're
So
looking to get rid of all the lines. Yeah. So
Yeah,
dots are,
here
there you
it's
go.
on.
Yeah. And then,
Yeah.
nice. I normally, is it not auto formatting for you? Oh, so generally I
I think
replace that with a new line. Because sometimes if you don't replace it
with a
with a
new
new
line.
line, it
Okay.
can squish things up.
Yeah. Okay. We are going to do the same for our main file. So here, let's replace this for the comments.
You know, I discovered the other day the dash dash empty flag on Flutter create. Just doesn't put all this gobbledygook in the files for you.
Oh, so there's a flag to do that.
Yeah, Flutter create dash dash empty. We don't,
Oh,
you've
I
already
didn't
done the
know
heavy
that.
lifting.
Yeah.
Yeah. But for the future,
So
dash dash empty.
here we can say it. Yeah, here it is.
Yep.
Specify. Yeah. No comments. Perfect. Yeah, that's a nice tip. So we don't have to use Ragged to clean everything.
Yeah.
Right. So here what we have to do is to actually import our proto package, right? As we did with the server. So maybe we can quickly put protos and also the path will be the same. Perfect. So we can have access to everything. And just for speeding up the example, we are not going to use any kind of state management or repository pattern or something like that.
Yep. Yep.
I think that we can just use the stateful widget that we
We'll
have.
use our imaginations.
Yeah. And yeah, probably there are like best practices to follow here, but I'm going to speed up. And we kind of would like to have a client channel so we can start communicating with gRPC. For this, we need to have a client channel. And we can have like this property. Maybe what we can do is to import the package progress, yeah. And because we are exporting the gRPC package in that package, right? So we can then initialize this channel in our init state, okay? So let's create our init state. And here what we can do is to create a client channel here. And the host will be, in this case, localhost, right? Because we are working in our machine. And the port, remember, we choose 8080, although it could be the one that we are providing to the server through the environment variables. And we also have to pass, let me see, in the client channel, the channel options. So for this, we are going to go for the channel options like the insecure mode, but this will depend on if you want to provide some SSL certificates, but we are going to go with the classes. And let's put everything on const. Okay. So here we already have our channel, and what we need to create after right now, like, would be the stub. So the stub will be just an abstraction, a proxy that we can use to communicate back and forth with gRPC and call actually our methods. So what we can do here is to create our stub. And to do that, let's quickly review how to use that. So basically, we will need to call another auto-generated class that we have. That will be the to-do service client. So let's put here a to-do service client. And this will be our stub. Okay. So we can also initialize this in our init state. So here, what we can do is basically to do service client, initialize, and send the channel, and that's it. We have our stuff, and we can start using it to interact with all of the methods available, like our get to do method. Okay. So yeah, let's hide the terminal. One moment. We can notice that here we have like the basic um, counter example, right? So what we can do is to maybe put a fill here to maybe what we can do is have the to do here. So it's one bit late. So we can display that to do in our main screen if we have one. So that's why it's nullable. But yeah, in our counter, this is really setting our state of our counter. We are going to delete our counter because we don't need it. Also this. And here what we can do is get our to do from the server. Okay, so we're going to replace this in our icon.
Nice.
And here maybe we can say, okay, if our to do is different than null, we can display maybe a text with the title. Okay, we have to use the.
Yep.
Oh, right. So, okay, this is here. And else we can display maybe a text that it would say get your to do.
I love it.
Perfect. Really simple,
Yep.
but we are basically testing the whole connection. And okay, so maybe what we can do also is to put this in a column so we can display more information. Actually, maybe we can display also the ID and whether or not this is completed. Okay, so this information will be an integer, so we have to parse it. And this as well, this will be a boolean, so perfect. I think this is complaining about the the const. Perfect. Okay, so basically, if everything works, we will be able to see actually the to do in our Flutter app uh, only after we click on the get to do button. Okay, perfect. So how we do that, right? We have to, on one hand, like start the server, right? So we are going to move to the server folder.
Starting the server sounds very helpful.
Yeah, totally. So we have to, if we go back to the server, we can see that we have our bin folder, and inside here we have the server, right? So we can simply do dart bin.server.dart, and the server should be starting. Okay, the server is listening on port 8080. So yeah, it's not like we can go to Postman and start testing in Postman. It's more difficult because yeah, this is another protocol, but we can run our app and see if everything is working. So here I can open another tab, and we can go to our client, right? So here what we need to do is to run our app, and I'm going to run it first on macOS.
Yeah, macOS. Absolutely the easiest way to get started.
Right.
No emulators.
No, yeah, no start. You don't have to start emulators, that's right. But we can actually test it in iOS or Android. The thing with macOS is it's not going to actually work the first time because we have to configure something, a special parameter
Yeah.
in the configuration.
The
But what was
entitlement.
the
That's
name?
that's what
The
it's called.
I think it is something like that, right?
Yeah, to be able to send network requests.
Yeah, so I'm going to show that this is going to fail, but then we are going to fix it. So yeah, so far, I mean, that is the whole example. Another thing that we are going to do that is really especially important in gRPC is that we are going to be capable of streaming different things from the server. So we are going to push information into our client. That's really nice. It has a lot of use cases. So here we have like our get your to do, and if we hit um, the button, like this won't work. But yeah,
Are you not
actually,
getting an error for this?
I'm
Shouldn't
not getting
it
an error.
be?
Yeah.
Oh, because you didn't put anything in get to do.
Oh, we didn't put the method. Okay. So here, what
I
we
thought
need
I
to do
missed
is,
that.
yeah, here we need to actually get our to do. So here we will need to pass the to do request that we created.
Oh, we
Get
kind
to
of
do
do need
request.
that counter actually.
Yeah, right. Maybe we can create a random ID here, right?
All right.
So maybe I think it's not that random. Oh, I have to explore
Whoa.
something.
While you're typing that, Postman added gRPC support.
Oh, I didn't know that. So
Crazy.
someone is
Yeah,
saying
that's cool.
that's very cool. I have to test that. Yeah.
Yeah, thanks for that
So
tip.
here, let me see math. Um, Probably there is a library. Oh, it's random. I think the
Yeah,
library, right?
yep.
Yeah,
I think
random
you have to
dot
import math
next.
for it.
Right. So next int, maybe we can have like 100. So
Perfect.
we can use the ID here. Okay, so here we are getting the to do, and we have, of course, to await this. And then we can set the state of the R to do to this to do, right?
Oh, right, because you added the keyword final there, so it actually had not set it on the widget yet. Nice.
Right. Okay, so now again, if we restart, we are going to actually do something in our get to button. And let's go back to this. And here we have the error. Okay,
Yes.
so to solve this, we can enter to
Yeah, and it said
the
operation
macOS
not
version.
permitted, socket stuff, blah blah
Right.
blah. So when you see that, you got to do what Franco's doing now. Open up Xcode.
Okay, so
Or
let's
are you gonna do it
quickly
here?
open. No, I'm going to open the
Oh, okay.
Xcode project. Okay.
I thought you were gonna show me the greatest trick of all, not opening
No,
Xcode.
not this time. Right. So
Wouldn't that be funny?
here, yeah, here would be um, signing and capabilities, outgoing connections. Okay, so we have to restart everything, but this time it's going to work. And yeah, that's the whole example. Let's wait a little bit. That is loading the macOS app. And the other thing I wanted to show, as I was mentioning, is how we can start streaming information from the server. So what we are going to do is to actually stream a to-do instead of getting one to-do and that's it. But let's first test this. Okay, so this is working. We have our to-do with a random ID. So we can keep going and that will produce a random to really basic, right? Okay, so the next thing would be to
So,
stream.
but before
Yeah,
we move on, I mean, streaming is going to be very cool, but I want to just recap kind of what we've done so far
yeah,
because we've been at it for about 50 minutes now, but a lot of that's been explanation, looking stuff up. You've written almost nothing, and we have completely strongly typed communication with the server. We on this very show, on the boring show, we've had shared code going from the client to the server, which by the way took more time than this to get working. But even that was not strongly typed. But here,
right,
the fact that the classes, of course, are strongly typed if you're sharing code, but the network requests themselves were never strongly typed before. And that is such a cool thing here. So if we change, never before has it been true that if you change how your server works, your client will get type errors. to remind you,
Right.
oh, I deleted that endpoint and I renamed it something else. That has never been a thing before. So this is really, really neat, and it's super performant. And like Gianfranco has said, we're about to start streaming. My dog is making a lot of
Of
noise
course.
here. Yeah, really, really, really neat. It just so cool.
Yeah, that's a really nice summary. And yeah, this was really fast, mainly because of the auto-generated files that we have. We didn't have to create our to-do class, our service. This is also auto-generated, so that's really fast. Yeah. But yeah, to give a little bit more about a more cool use case, we're going to stream this to-do. So we can go back to our proto file again, um, where everything happens. So if we go to our proto package, maybe what we can do here is, instead of having a get to do that returns a to do, we are going to return a stream of to dos, right? So maybe we can create another method that will be get to do stream, maybe. And yeah, the actual request would be the same. We can pass the well, it won't make sense because actually we are not going to create a to do and send it to our client. What we are going to do is kind of like have a stream of to do and
Mm-hmm.
send it and push it to our client. So maybe we can create a separate method that will be creating our to dos and sending to our client in like streaming, right?
Yeah, we could also the stream could just once a second it could just add a random to do to the
Right.
stream, and then the front end could maybe store them all and like show them in a list view or something.
Yeah, we can do that. So what we have to do here is to provide a stream of to do, and that's it. That's really simple. We only need to modify using this keyword. We can actually also stream here from things from the client. Maybe we can find a use
Oh.
case for that. But yeah, we can either have a single call, we can have streaming from the server, from the client without the server, or both. So that will depend on your use case, but you have this bi-directional communication that you can yeah, get an advantage for that. So what we need to do right now is, of course, to go to our commands, proto C command again, and auto
So do,
generate
do
this.
you are you intending to leave the stream keyword in the parameter on line
Oh, that's
15?
right. Yeah, maybe
Yeah.
we can start simple with the yeah, with only streaming things from the server. Okay. Okay, so now if we go and see about, I can generate the proto files. Now we can see that our server has an error because we have to implement the other method.
I love
So
these errors. Hey, you
yeah,
forgot something.
yeah,
Just the
that's
best.
that's nice. So maybe we can create the missing override, and in this case, it is the exact same method. We have our service call and the get to by ID request, but we have a stream of to dos instead of a future, right? So here, what we will need to do is to actually yield a to do instead of return it. So what we can do is maybe what would be the best way to do this? So maybe we can have a to-do controller. So here we can
We
use.
could just have a loop that that awaits a duration of 1 second and then emits
Yeah,
another one.
but since
Like it
we're
could be
okay,
while
so
true.
okay, so we have a well true. Okay, perfect.
Yeah,
Well
let's be
true.
real simple here.
Yeah, and we can yield a to do, right? So maybe
Yep.
we can grab
Just copy.
everything from here.
But maybe a random number, right?
Right. So maybe here.
Although it's funny, the request specifies a number, so our hypothetical is getting a little fuzzy here, but bear with us.
So maybe here we can, next
Next
cent
in,
and
yeah.
100, and we have our to do here, and we need to yield this to do. So actually, for doing this, we have to
Async
have the
star.
async star. Yeah.
And for anyone who's
here,
not aware, async star. First of all, there's a great series on YouTube called nope, I forget the name, but Andrew Brogdon, one of the original Flutter DevRel people, has a 5-part series on YouTube. I think the series was called Flutter in Focus. Anyway, it's asynchrony in Dart. Goes through all this, but async star means that your function returns a stream, and every time you use the yield keyword, the object that you yield just goes on the stream.
right.
And so that's what we're setting up here.
Perfect. So we forgot about the delay. So if not, this is going to provide a lot
fast.
of So let's delay it a little bit. This maybe a second would be reasonable enough to notice, right? So maybe we can put it.
Perfect. Yeah. After the yield,
here.
either the beginning or the end. Honestly, either.
Okay. Perfect. So here we need to modify our client, our Flutter app, so we can start receiving these messages from the server once over like in a period of a second, right? So if we go back to our main file, we had our to do here, and we will need to have a stream of to do this time instead of a single one. And maybe what we can do is to then create a stream of to do. Okay. So
exciting. I've not used a stream builder widget in so long. But I foresee it in our future.
Yeah, that's right. I mean, I used to work a lot with stream builders before using the Flutter block library, but then it kind of like it was pointless, right? Because Flutter block kind of like hides the whole implementation. But yeah, back in the old days,
it's still a stream builder. It's just well disguised.
Right. So yeah, back in the old days, I used to deal with a lot of streams and RX start. So this was like remembering how I used to work, but in a sense. But yeah, the to stream, maybe we can put it as null also, so we don't have to initialize this here. And what we can do is to initialize our to do stream. Let's put it private. And we, of course, have to call the stab, right? So the method would be get to do stream. And our request would be the same one that we use here. We can copy. Okay, now this ID will be pointless, but we just have to put it there. And here what we will have is our stream of to-do. So what we can do now is to have a stream builder, right? Instead of our column, maybe we can put here a stream builder. And let's first provide the stream. The stream will be to-do stream. And then we have to provide the builder, right? So for the builder, we need the context and the snapshot. Okay, this is getting really long line, but I think that's it. Okay, so here in the snapshot, what we can do is to actually see if there is any data. And else we can print or show maybe loading, because we will wait. Yeah, we have to cover that case in case nothing else is in the stream.
Yep.
So if this has data, we can probably grab our to-do from the stream. So let's do that. And we can display a column with our to-do, right? And we have to actually return the column this time. And that's it. I don't know if we have to actually parse this or be already. But
Yeah, I'm not gonna lie. I've not done this in a minute, so I'm not really sure either. Let's find out together.
yeah, so here we can remove the null operators. That's cool. And here I'm having an error. Let me see. Oh, I think I didn't
Oh,
return this.
return.
Yeah,
Yeah.
yeah. Perfect.
I think this is gonna work. I think this is right.
Okay, let's cross our fingers, right? So I'm reviewing a little bit. This get to do one be call. I mean, can be called, but it will be the other method, and we are calling directly the stream and using a stream builder to present the data. So if we go again, let's rerun our server, right? Because we made some changes.
Good idea.
And let's rerun. Oh, we could actually have used the hot restart. Yeah.
Yeah.
Yeah. But okay, just my bad. But
This
yeah,
is
we
called
had
the
to wait.
cold restart.
Yeah. So here, yeah, if everything works, we are going to see really fast, not really fast, like in 1 second, yeah, how random to-dos are heading to our app. So apparently it worked.
Nice.
Great.
Well done. Flawless. By both you and gRPC. Maybe the G stands for Gianfranco. Have we thought about that?
It could be, right? Yeah, that's another coincidence.
Yeah, no, we'll have to check. We'll have to ask. Look at this. We are streaming data from the server. This is so cool. Think about what you have to do to get this functionality any other way. You have to, definitely use a WebSocket. And that's not the end of the world, but oh boy, was this easier. And like you said, it feels like you call a native method that's just like locally available, right? We're just dealing with a stream on both ends. And then all of the guts to serialize stuff and get it on the wire and manage the connection, never had to think about it. Never thought about it at all. And it was type safe across the boundary, across the network request boundary. Just really, really neat. Really cool.
Of course. Okay, so yeah, that kind of like wraps up the whole implementation of the full stack app, like with our client, with our server, right, with our product package, everything. We can share this package between client and server. We saw like the implementation of a method that is streaming information. Maybe what we can do now is test the other streaming capabilities. We mentioned that you can not only stream something from the server, but you can also stream from the client. So you could potentially like start streaming things from the client to the server. Um, I don't have a really well thought example of this, but it could be something useful. So
No, I
yeah.
think folks get it. Yeah, no, I think I think we get it. Now but if you did that on the front end, you'd just have a stream and you'd just add stuff to the stream and then it would show up on the back end.
Right. Yeah.
Yeah.
Yeah. Totally. I mean, you will
Amazing.
be basically initializing your stream in your front end, and then like you will be streaming information to the backend to gRPC, and then something will happen. Maybe you can log everything, print it, we can see it, or yeah, I mean, we can either do that to test, or another thing I was also um, wanted to show is like how this can work in different platforms. Maybe we can open iOS as well and play around. Maybe we
Mm,
can send messages between both of them, because here we are streaming information to one client, but maybe
hmm
we can stream information to multiple clients at the same time, and they all are going to see
hmm
the same to do instead of like different ones, right?
Right, right. Well, I think that is also, you know, a pretty good a good example, but I think we've covered stuff quite nicely here. There are a few questions that we could get to. Some there's folks have asked a couple of good ones,
Okay.
and I think that is probably a nice way to finish. You know, in terms of on iOS and Android, it's going to look just like this, you know, which is
Right.
amazing. Um,
Yeah.
but it's not. There shouldn't be like a big jump there.
Yeah.
So we did get one comment earlier. I kept referring to the message as a class, and uh, Tok Tokchukov says the message is more of a struct than a class. I think, as it doesn't contain any logic, and I think that's a nice way to put it. Um, you know, the message itself is definitely a struct, but it is mapped one to a class after you run the proto C command. So the boundary between the message and the class is, you know, it feels thin sometimes. So, but I think you are technically that is a better way to put it for sure. Now, Gianfranco, I think the next few here, I'd love to get your takes on first, and then maybe I'll add commentary at the end. Whatever thoughts I might have, but I think there's some good questions here. So Tim asks, the state management block or riverpod or others work the same with gRPC on the front end and the back end. So I think this question is like,
Yeah.
how does using this impact your state management?
Right. I mean, I know that in our client app, we actually only present a simple example where we play around with a stateful widget. But this, when you deal with this, you have to actually have a state management solution such as block or riverpod. And if you're following a good structure or a good architecture, that won't impact really, because your block will be kind of like calling probably a repository, and that repository will call ultimately gRPC by using what we saw, that is a client channel. So if you have everything in place, you can still use like Blog or Riverpod in Flutter, and that won't be. I mean, the whole point of Blog is just to uncouple your front end, your presentation layer from whatever data source you have. So if you're using REST or WebSockets or gRPC, that would be the same. So yeah,
Yep.
that won't impact. Yeah.
Uh, Nothing to add. Well stated. Okay, next question. This one came up a couple of times. Oh, actually, let's stick with one from Tim here because it's a little more related. Then we'll jump to some other questions. Tim asks later on, how are your typical status codes returned in a traditional REST API architecture? So I interpret this as saying like, how do I differentiate from, you know, a success from an error, right? Normally you can check, is it a 200? Is it a, if I created something, I maybe expect a 202 or 204 or kind of however you set it up. If it's not there, it's a 404. How does that work in this setting?
Right. Yeah. Yeah. I interpret the same, because yeah, you clearly have like status codes in REST, and everyone, each of them are really telling you if you're not authenticated, or if you have like, I don't know, different errors such as 404, right? But in this case, I think that you, of course, I mean, we didn't saw error handling. There is a separate documentation for that, but you can always like throw your exceptions, because you will have the same problems. Like you will have to authenticate the user, so you can like if the authentication is not working, you can throw in a gRPC error and you can handle that into your client, or you can send like custom exceptions, right? You can always
Mm-hmm.
do that, but I don't think that there is a map between like status codes to actually like gRPC. But yeah, I definitely do that. Like have like maybe we didn't see this, but maybe we can have an interceptor that is authenticating each call. If something is not working, I mean you're not authenticated, you just send a gRPC error, and then if the user like is authenticated, you can perform your logic and throw custom exceptions. What it could happen is that the channel connection is not working, so you have to handle that in case you are, for example, streaming something. So you might present something to the user. Actually, I remember we didn't also cover this case, but I remember when we opened the channel, we could have closed it whenever the stateful widget is disposed. I mean, that wasn't the case,
Mm-hmm.
but whenever we
You would
dispose the
certainly need to
widget,
do that. Yeah.
yeah, you'll need to close the channel so you don't have something like streaming unnecessary things.
Yeah.
And yeah.
Now, part of the way this works, where Google uses protobufs. So, like for example, the Firebase SDKs. All the communication happens using protobufs, and instead of just returning a to do, which was a perfectly reasonable kind of shortcut for this demo, instead of returning a to do, if you look at the documentation, you'll see something like, the whatever request and the whatever response. And so instead of just returning that raw object, you can return something that wraps it. And then you can have like an error code in there. The error code can be its own enum essentially,
Right.
and which is like also a gRPC object. And then on your
A
client you
protobuf,
just
right?
check. Yeah, exactly. Yeah.
Right.
And then on your client you check, did I get my dot to do or did I get my dot error? And you wouldn't necessarily, you could if you wanted, I guess you could set 200 to equal okay and 404 to equal not found if you just kind of wanted to keep that. But however you set up your errors at that point. All right, another question. This came up a couple times about like data migrations. As your data evolves over time, you add new fields. I think this was the first time I saw it in the chat. Daniel says, "What's a recommended way to handle API changes? For example, adding new properties to models or changing optional to required. Is there a way to version these changes?"
Yeah, actually, there's a way of versioning. The in the documentation, it says like, but yeah, it's true that whenever you make some changes, it will impact into your clients that are using the same protobuf models. So I think you should see like what is the best strategy. This is like always something um, that is a problem, especially like if you're using, for example, in REST is also a problem because if you add something, you have to you will have your client that is breaking because it doesn't have the last parameter. But in this case, as everything is auto generated, at least your client will be noticed that change like really soon, as we saw, like everything is typed. So yeah, I guess that versioning like your product path should be a really good solution to implement. I think I'm not hearing you.
Yeah,
Uh,
sorry, I muted myself.
were
My
you
chair makes
okay?
noise. Yeah.
Okay.
um, so yeah, Pascal asked this question with another good angle. He said, you know, this gets at kind of an awkward point when you're always talking about updating a distributed system that has to talk to itself. So how does this deal with updates to the model? Will old apps be able to talk to the updated server? So yeah, what about people who don't click that download new app version and they're running the old protobuf? I know some thoughts about how this is handled at Google, but I'd love to first hear, how you handle this
Yeah,
at Samio.
yeah, because I mean the thing is that for me something that we didn't mention is that this kind of gRPC is also used in microservices architectures, right? We saw an example of using a client and a server, so really communicating at the front end with the back end. But this is really how lots of systems like that uses microservices architecture. It's really handy because as um, we saw, like you can, especially in microservice architectures where you can really choose whatever language you need for your use case. That's really handy because you will be sharing your definition and you can share it across multiple uh, programming languages. So so yeah, in our case, we've deal mostly like with Dart. So in our case, it's really easy because when something changes in the protobuf, mainly because of the server change, you have to only like um, update your Flutter app and that's it. But I guess that if you're having a microservice architecture, you have to have that strategy well placed because maybe not all your services need to update. Maybe they have to continue working as they did without new definitions or changes. So yeah, I think that there will be a real problem mostly in your microservice architecture, especially in the backend. But
Yeah, a way that this works at Google is essentially required fields are swear words, and you're not allowed to add required
right,
fields because you can't trust when clients will be updated. Even a web client, someone could just have an open session and not refresh the page, and if the server changes out underneath them, all future visitors will be fine, but current viewers could be totally hosed. So, no required fields are allowed. Now,
right.
that creates its own thing where now you can't trust any of your fields, even if you know this field is actually required. I just pretend it's optional for like backwards compatibility. Do you really want to carry this burden into perpetuity of like, is the required field there? Oh, weird, it was again. So you could version it for sure. You could just add a new endpoint that returns, the response v2 or something, and it returns the updated model with the required field there. And then old clients just keep calling v1, and once in your logs you haven't seen v1 called in a month, then you can finally delete it, something like that. But it's definitely, that's a tricky thing for sure. um all right, there was another question, this one a bit lighter. uh Wajisek, I don't
Well,
think
yeah.
I was close there, but I wish I was closer. uh Asked, said/asked, I thought of creating a chat in Flutter using gRPC. Is this a good idea? What do you think?
Well, I mean, naturally, you will think about that because you have a bi-directional support, right? So, yeah, if you're dealing with a chat, the most common way, like to have, for example, a front end communication with a backend is REST, right? And yeah, REST is not particularly a good use case for a chat because you have to send information between the your front end and your backend, so that can be actually pushed to another client that you need to chat. So in this case, as we can push information, this could be something that you could actually implement the gRPC. Why not? Because well, we didn't see it, but if we started another client, we can actually play around a little bit and share the same streams. So we can push messages between one client and another one. It could be done, but yeah, also I guess that. a more suited technology for doing that would be also WebSockets. So you can also try WebSockets to have that communication uh,
Yeah,
in a chat, right?
I would. Yeah, I would say, in a world where gRPC didn't exist, in a world, there would be WebSockets would be essentially the only kind of sane way to do
Right.
things. Like if you just tried to use old school HTTP requests and polling and whatnot, it's like you'd have the worst chat app ever. So WebSockets would always rule the day. But I think gRPC is essentially, you get that kind of low latency immediacy of WebSockets, and it's just like, it's not the same as WebSockets. The implementation is different than where the ones and the zeros are on the wire is different, but that doesn't really matter for most of us. I honestly just think of gRPC as WebSockets, where I got a lot of code generated for me, and it's type safe
Right.
across the boundary. I mean, it might literally be on an actual WebSocket under the hood, and then I don't really know how it works. That's one of the great things about gRPC. Like, you don't have to know every single part of the stack all the way down, but it just it's really, really, really efficient in a way that we kind of all expect out of chat apps. So I think it's a great choice for that.
Yeah, I guess that's right. That it will be more efficient probably in your mobile phones. That maybe I don't know. Like nowadays, it's you can really have like a really good mobile phone, but there are other ones that other mobile phones that are not so advanced. So you can push that binaries instead of like string-based messages more faster, and that would be like a huge improvement in terms of efficiency by
Yeah,
only using gRPC.
yeah, absolutely. Well, Gianfranco, I think we have gotten to the end of the questions, and I, the demo was perfect. Everything worked first
Thanks.
try,
Right.
except when we knew it wasn't going to work because of the entitlement. So
Yeah.
bravo there. And man, I had a great time. I hope you had a great time. I think the viewers had a great time. But this seems like a good time to call it. Any last thoughts, Gianfranco?
No, I mean, yeah, I had a great time. I really enjoyed it. It was actually doing the live demo was really cool. And yeah, any last thoughts? I don't know, like I guess that maybe if you haven't tried this technology, I guess this is a really great starting point for doing that. It really caught my eye, especially because of the basically sharing code between front end and backend. We, as Flutter developers, we always struggle with, okay, we have to deal with a different programming language in another backend. So why can't we use Dart, right? So and yeah, that's why I keep exploring different alternatives for doing everything full stack. And in terms of gRPC, you can really use Dart or whatever language you like. So that's really another point on top of gRPC of all the advantages we name it. So yeah, and it's for me it's really cool to auto generate these things. It works like magic, and you can share your product files, and that's awesome. So if you haven't tried, give it a try, but because it's a cool toolset, you could have it in. And as you said, Craig, this is used by Google, so it will uh, let you know how they work. So yeah, I really enjoyed to be here, and yeah, hope to be here soon.
Awesome. Yeah. Well, I think that's a great place to leave it. So, everybody, I think I'm going to be off next week, doing some prep for Google I/O coming up in May, but I'll be back after that. So, until the next episode, have a good one, everybody.
Okay, bye.